Welcome everybody, I'm Dr. Zucchikin from Elettronica Veneta, and today I'm gonna tell you briefly how this model MCM12C works. So let's introduce the apparatus. The main unit is MCM12C and it has to be connected to the external unit TY12C via this connector here. Then power supply has to be provided to the module via an external power supply, via this cable here, or by providing -12 ground and +12 volts via this terminal on the top. So now let's proceed with the software in which all the connections over the module are explained. Once you launch the software, you get to the main page, which is the presentation of the module MCM12C. Then by acting on the button on the upper left corner, you get to the connection page in which you have the full supervision of the plant, and then you see all the hardware connection that has to be performed on the hardware. The first block explains the jumpers that have to be connected on the main unit, and then you got the terminals which link the main unit to the data acquisition board. Let's perform the hardware connections. So now let's perform the cable connection between the unit and the EQ board. So first the ground connection, common. Then you got the output of the flow signal converter to terminal number A0. Then you got terminal 14, which is the output of the level transducer in 1. And then you got the output wired to an input here. And at last you got the output 0 wired to the input 2. At last, the DAQ board has to be connected to the PC via the USB cable. So now let's perform the calibration of the 0 on the external unit. You have to fill up the tank up to 2 liters before starting the measurements, and then up to 3/4 of the lower tank. Above all, it's around 4.5 liters of water. Just enough for the pump to have some water to grasp. Then you have to open the faucet here in order to let the water drain down and regulate it up. The level goes to the red line, meaning 0. Now let's work with a level control. So in my software I can set the set point, which is the level of my tank, and this is mapped on the full range of our sensors. So 0 volt, meaning 0 level, which we have calibrated at the beginning, and then 8 volts, meaning 200 millimeters of water. So with this control up here, you can select the mode of operation. So let's perform SL first, which means level control. Once the model has been powered up, it received the set point. So for example, 4 volts, meaning around 1 liter of water. And now we can see the pump, which is doing its work. I have a fully closed faucet, so once it gets to around 1 liter, it's gonna stop. And that stops. So Actually, by acting on the faucet here, I can regulate the discharge of the tank, and so I can balance it with a recharge by the pump in order to establish a almost constant level. In the central section of the main unit, we have 3 potentiometers concerning the 3 constants of the PID control. So you got the proportional part, the integrative and derivative part. So by acting on these potentiometers, I can regulate the dynamics of the PID process. So now going back to the PC, I can see the numerical indicators of my level and of my flow rate. So by acting on the set point here, I can see the system is responding fast enough for my process. So let's perform now a flow rate control. And in order to do so, we have to use an oscilloscope, which is not mandatory, but it's nice to see. We connect the ground of the probe of the oscilloscope to the ground of the main unit, and the probe to terminal 1 of the flow rate transducer. Then I switch jumper 4 to jumper 3 in order to perform a flow rate level control. In my main software, I go to S.p.A state and I perform a triggering of the set point. On the oscilloscope, I can see almost a square signal coming out of the transducer, and the circuitry on board converts it into a continuously variable voltage between 0 and 8 volts. So by acting on my set point, now I am regulating the flow rate. And then I see the action of the PID control. And I also hear it on the pump. By acting on the PID constant on my main unit, I can change the process to be more snappy or more slow. So in my front panel, I can see values of the variables which are closed to the set point. So I'm 3/4 range here in my set point on a full scale of 2 liters per minute. So it should be around 1.5 liters per minute, and we are there. So these are the 2 main basic experiments we can perform on MCM12C. For all the others experience, please refer to the manual.